Hello friends, welcome to SSP Math. Next problem of eigenvalues and eigenvector is find the eigenvalues and eigenvector for lowest eigenvalue of matrix A. Means we have to find all eigenvalues of this matrix and eigenvector for lowest eigenvalue. So for eigenvalues, first we have to consider determinant of A minus lambda I is equal to 0. So what is this determinant of A minus lambda is 1 minus lambda 0 minus 4 then 0 5 minus lambda 4 minus 4 4 3 minus lambda equal to 0. We have to expand this determinant using formula lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0, where s1 is sum of diagonal elements of matrix A, that is 1 plus 5 plus 3 is equal to 9. s2 is sum of minors of diagonal elements of matrix A. So 1 minor of first diagonal element is 1, here its minor is 5 4 4 3. Okay, then plus second diagonal element is 5 and its minor is 1 minus 4 minus 4 3, and plus third diagonal element is 3, its minor is 1 0 0 5. So if we solve this, then we get 15 minus 16 is minus 1. Here 3 minus 16 minus 13 and plus 5 is equal to minus 14 plus 5 is minus 9. So S2 is minus 9. Now we have to find determinant of matrix. So determinant of matrix is equal to 1 into its minor, that is 15 minus 16 is minus 1 minus 0 minus 4 into its minor is 0 plus 20. So what is this? 20 into 4 is minus 80, minus 80 minus 1 is minus 81. So put all values in this equation, then we will get characteristics polynomial lambda cube minus 9 lambda square plus s2 is also minus 9 lambda, okay, and minus determinant is negative here, so minus minus plus 81 equal to 0. So this is the characteristics polynomial of given matrix. Now we have to find roots of this characteristics polynomial. So for roots we can use any method, okay, for roots we can use any method. So if we use calculator, then again go in mode, choose equation, up in equation choose degree, we want the root of third degree polynomial, so press 3, then a value of a is coefficient of lambda cube, that is 1, then press equal, value of b is minus 9, then value of c is minus 9 and value of d is 81. If we press equal here, then we get first root 9, first root is 9 means lambda equal to 9 here, then second root is minus 3 and third root is plus 3. Now we can check our eigenvalues are correct or wrong. So minus 3 plus 3 0, so lambda equal to 9, sum of eigenvalues is equal to 9, product of eigenvalues is equal to determinant of matrix, so 3 into 3 9, 9 into 9 81 and minus 10, so minus 81. So our eigenvalues are correct. Now what is our question? Here we will get, here we got 3 eigenvalues of given matrix, but we have to find only one eigenvector here, because in our question mention a find eigenvector for lowest eigenvalue. So out of these 3 eigenvalues, which one is lowest? That is minus 3. Okay, so we have to find eigenvector for lowest eigenvalue, and that lowest eigenvalue is lambda equal to minus 3. So for eigenvector we have to consider characteristics matrix A minus lambda into x equal to 0, that is A minus lambda into x matrix is 1 minus lambda 0 minus 4 then 0 5 minus lambda 4 minus 4 4 3 minus lambda into x y z equal to 0 0 0. This is equation 1. So you have to find eigenvector for lambda equal to -3. So put lambda equal to -3 in 1. So if you put lambda equal to -3 in 1, then equation 1 becomes minus minus plus here. 1 plus 3 is 4, 0, minus 4, 0. 5 plus 3 is 8, 4, then minus 4, 4. 3 plus 3 is 6 into xyz is equal to 0, 0, 0. Now consider any two distinct rows and apply Chromos rule. I think here all rows are distinct, so if we consider R1 and R2, so by R1 we can write 4x plus 0y minus 4z equal to 0, and by R2 we can write 0x plus 8y plus 4z is equal to 0. 2 equation 3 unknown, how we solve? Using Chromos rule. So if we apply here Chromos rule, then we have to write x upon determinant of coefficient of y and z from first equation, that is 0 minus 4, from second equation 8 minus 6 is equal to minus y upon coefficient of x and z from first equation 4 minus 4, from second equation 0, 6, not 6, this is 4, 0, 4, okay, and equal to z upon coefficient of x and y from first equation 4, 0, 0, 8, okay. So if we expand this determinant, then we will get 0 upon minus 32, minus 32 not plus 32, minus minus plus is equal to minus y upon 4 into 4 is 16 minus 0, that is 0, is equal to z upon 32. So if you multiply throughout by 16, then we will get here x upon 2 equal to y upon minus 1 equal to z upon 2. Means if we divide by 16, then we get x equal to 2, y equal to minus 1, z equal to 2, and therefore eigenvector x is equal to xyz, that is 2 minus 1, 2. So this is the eigenvector for lowest eigenvalue. Sometimes question may be asked, find the eigenvector for highest eigenvalue for same problem. So here which one is highest eigenvalue? 9. Okay, so you try for lambda equal to 9 for highest eigenvalue, you find the eigenvector. So next problem is find the eigenvalues and eigenvectors for the matrix A is equal to 14 minus 10, 5 minus 1. So this is the 2 by 2 matrix. So problem is very simple, method is same. For eigenvalues we have to consider determinant of A minus lambda equal to 0, that is here determinant of A minus lambda is 14 minus lambda minus 10, 5 minus 1 minus lambda equal to 0. So how we expand this determinant? Again for 2 by 2 also one formula is there, lambda square minus s1 lambda plus determinant of A equal to 0. And here we have to find only s1. What is s1? s1 is trace of matrix, that is 4 minus 1 means sum of diagonal elements is equal to 13, and determinant of given matrix is minus 14 plus 50. So minus 14 plus 50 is, yes, minus 14 plus 50 is 36, okay, and therefore characteristics polynomial of given matrix is lambda square minus 13 lambda plus 36 equal to 0. Now we have to find roots of this characteristics polynomial. If we find roots of this characteristics polynomial, then we will get required eigenvalue. So how we find roots? Again go in mode, choose equation, in equation choose degree. So here second degree polynomial means quadratic case, so choose 2, okay. Value of A is 1 here, value of B is minus 13, and value of C is 36. If we press here, then we get first root is 9 and second root is 4. So lambda equal to 9 and 4, or two numbers whose sum is minus 13 and product is 36, that is minus 9 minus 4, means lambda minus 9 and lambda minus 4 are the roots. So these are the eigenvalues. Now we have to find 2 by 2 matrix, so it has two eigenvalues, okay. So we have to find eigenvectors of each eigenvalue now. So for eigenvector we have to consider characteristics matrix A minus lambda into x is equal to 0, that is A minus lambda matrix is 14 minus lambda minus 10, 5 minus 1 minus lambda into x, that is xy say equal to 0 0. This is the characteristics matrix, denote this by 1. Now first take, suppose if we take lambda equal to 9 eigenvalue. So for lambda equal to 9 we have to find first eigenvector. So put lambda equal to 9 in equation 1, then equation 1 becomes 14 minus 9, that is 5, okay, and minus 10, here 5 minus 1 minus 9 is minus 10 into xy equal to 0 0. Okay, so here 2 by 2 matrix is, so take any one row. So from first row we can write here 5x minus 10y equal to 0. Okay, and how we find x and y, or this equation can be written as, if we divide by 5 here, then we will get x minus 2y equal to 0. So we can solve this problem using Chromos rule also, or without Chromos rule we can take here one equation, two unknown is, suppose y is equal to k, then we will get x is equal to 2k. Okay, and therefore eigenvector x1 is equal to k2k. K2k, how we write? K take outside, 1 2. This is one way. Another way is using Chromos rule, we can write x upon equal to minus y upon. Okay, so x upon, write down coefficient of y, that is minus 2, and equal to minus y upon, write coefficient of x is 1. So x equal to 2, y equal to 1, minus minus plus 1. And therefore first eigenvector x1 is equal to 1 2. Okay, then we have to find second eigenvector. For second eigenvalue lambda is equal to 4. So put lambda is equal to 4 in 1. If you put lambda equal to 4 in 1, then equation 1 becomes 14 minus 4 is 10, minus 10, 5, and here minus 5. Okay, into xy equal to 0 0. Again take any one row, suppose from first row 10x minus 10y equal to 0. So if we divide throughout by 10, then we will get x minus y equal to 0. So same as this, if you use Chromos rule here, by Chromos rule x upon coefficient of y is minus 1 and equal to minus y upon coefficient of x is plus 1. Again minus minus get cancelled, x equal to 1, y equal to 1. This is one way. Or another way, you can take y is equal to, or y equal to k, then we will get x equal to k. So kk, so second eigenvector is 1 1. Or in terms of k, if we write, then that becomes kk, and kk, how we write? Take k common, 1 1. Okay, so this is the second eigenvector for lambda is equal to 4. Okay, thank you.